This is a video to go with the 7-2 lesson. These are things that we did talk about in class, but sometimes students need to hear again or see again in order to make some sense out of the algebraic manipulation for the integrals that we're working with. So we're going to be working on inverse trig showing up in the integrands that you're working with. So I've got the two derivatives here. And what it might look like is after you've tried a few different u substitutions and you can't find one that works with your expression, if you've got certain sums, meaning addition or subtraction, certain sums or differences of things that remind you of some of those inverse trig derivatives, you might want to think about how you could manipulate the algebra to have that as your integrand. So on the first one, we've got the integral of 2 divided by the quantity p squared plus 16 dp. So in that form, it's not in the form of a derivative that we know. However, if we could get that to be 16 of something squared plus 16, then we could factor the 16 out. So instead of picking a u here, what I'm going to pick is what p squared is going to be replaced by. I would like p squared to be replaced by something that is 16 of something else squareds when I go to do some u substitution. And if I do that, then I can base my entire planning phase off of this idea. So if that is truly what that is, then p could be replaced by 4u. And then we could still get our du dp that we will need. So in this case, dp is 4 du, taking the derivative. And therefore, I can also write that du is 1/4 dp. So when I go to look at what I'll be doing in my substitute stage, I will need, in order to get my correct differential in there, I'm going to need a 1/4 dp that I don't have right now. So I am going to multiply one in and still bring that 2 out front. I would like a 1/4 and then the dp so that I can satisfy changing over to du. And in the denominator, I can already see what I'm going to be using. I'm going to replace p squared with 16u squared, so I have my substitution. So p squared plus 16. So I didn't pick the p value, the u value. I picked what I'd like it to be looking like. So when I go to actually calculating with u's and subbing in, I've got an 8 out front. And then my 1/4 dp, all of that becomes my du. And I'm going to have 1 over, and instead of p squared, that's going to get replaced by 16u squareds plus 16. At this point, I almost have an inverse trig function in there, the derivative of one anyway. So I'm going to factor that 1/16 out of the denominator, or actually the 16, but it becomes a 1/16 because of its location. And then I will have the integral of 1 over u squared plus 1 du. And in now being ready to do that, I recognize that that's the derivative of inverse tangent. So I have a 1/2 out front, and I have inverse tangent of u as my integral, plus a constant. And therefore on my u sub step, I'm going to have inverse tangent of. Now when I go back, you don't have what a u actually is. So go back to this one and say a u is really a 1/4 p. Plus a constant. In the second example, I see in the denominator what again looks a little bit like it could be an inverse trig function. So I've got 1 minus 16x to the 4th all under a square root sign. And what I'd really like under that square root sign is 1 minus something squared. So in thinking through not what I want to pick as my u, but what I want to replace that 16x to the 4th with, I would like that 16x to the 4th to be replaced with a u to the 2nd power so that I can get the denominator to be the square root of 1 minus u squared. That's reminding me of the inverse trig derivative. So therefore, I'm going to take the square root of both sides and keep only the positive one here. So I'd be letting u be 4x squared. And then I can go ahead and continue my planning here. So du then would be 8x dx. I'm going to start to look for the things that I'm going to need in order to make that happen. So as I look, I'm going to need a factor of 8 that I don't have at the moment. So if I want to include a factor of 8 in my planning step, I'm going to need the 1/8 out front. And then I'm beginning to see all the components of the things that I will need in order to make this happen. So I'm going to do my replacement step and my u sub. So I'm going to have 1/8. The integral of my entire 8x dx is going to get used up in order to convert my differential. I'll have 1 over the square root of 1 minus, and that 16x to the 4th is getting replaced with u squared. Now when I take the integral, find the antiderivative, that is inverse sine's antiderivative. And then I'll go back to subbing exactly what the u is that I found in my plan stage.